And yeah, so let's start with prefix sum. Prefix sum. Okay. Now prefix का मतलब क्या है? Like, what is the English meaning of prefix? Like,
So पहले वाला before
what is it?
before like some part before starting.
Can't hear you clearly. But
Like before वाला part like starting.
yes. So if I have, let's say, A, B, C, D, a prefix is this part, like starting to some particular element. So prefix usually we use when it is like uh, apply, like, uh, advantage and disadvantage. Like in English, if you're writing advantage, if you just change the prefix, disadvantage, this part is a prefix. Which is basically the first element, the first part of a particular thing. Okay. Now coming in terms of arrays, coming in terms of programming, DSA, whatever. Let's say you have an array. Okay. Here a prefix is basically up to this point or up to any index, what is my value? Okay. So up to, let's say I want up to one, like 0, 1, 2, 3, 4, 5, 6, 7, 8. So I want, let's say, up to index 3. I want something that is a prefix. And the sum part is what it defines. I want prefix sum. That means third index. Like I want every element ka sum up to the third index. Okay. Does it make sense till now? That is prefix sum, definitely. Now let's say I have an array like this: 1 minus 1, 2, 10, 4, minus 2, 4, 1, 7. A prefix sum is basically I just convert this array into a new array. Why are we doing this? I'll explain. But of the same size, people do it offset, that also works. Okay. Let's say I add another element here. Okay. My first element is always Z because before my zeroth index, what is my sum? 0, right? Now up to this, what is my sum? 0 plus 1. Then up to this, up to first index, what is my sum? 0. 1 minus 0. Same goes for here. 2. Then we go here, which is 12. What are we doing? Like, should I always, like, if I want to calculate for this, will I keep adding 1, 2, 3, 4 terms? Yes, no. Or is there a smart way to do this? I would like the people who don't know prefix sum or are just new to this would answer that better. Whatever you want to say, let it be wrong. You will only learn. I know. भाई लाइव सेशन आने का बेनिफिट यूज करो भाई इंटरेक्टिव हाँ ओके Well, now let's say I want to calculate for 4. I already know this sum now up to 3. So what do I need to do to make it up to 4? Just add 4 to my previous value. So that is what you do. 12 plus 4, 16 minus 2, 14 plus 4, then 19, then 26. So this is my prefix sum. What does it tell me? Basically, if I want sum from 1 to from 0 to let's say 3, I can directly go to the fourth index because this is one based indexing. So I know there are 4 elements here. I directly go to the fourth number and I directly say, okay, my sum up to 4 up to 3 is 12. My sum up to 6 is let's say 18. Stuff like that. Okay. So a basic question which I can which can be made is given array for q queries, answer sum of prefix up to x. Okay. And okay, this is the standard question which can be asked. And this is basically what we did over here. Okay. I had this array. I transformed it into prefix array. And my queries just get solved by this. Now, any doubts in the logic or algorithm what I'm using to calculate this? If you have, raise hand, speak out, chat kar lo, whatever you want. Hmm.
No.
Perfect. So now let's move on to the code and then we'll come to the more applications to this because this might seem very easy to do, but prefix sum is not only used like this, there is a very amazing way to do this. Let's just make lecture 3. And prefix sum. Ah, so firstly, I'll make the template. I will do this. You get n as the input and then you make a vector, right? This you might have learned in the first lecture. Now I want to make a prefix sum array. How do I do that? Prefix sum size n plus 1. Why am I doing size n plus 1? Because it makes my life easier. Why does it make my life easier? I'll tell you with respect to code, but in general, my first element is always 0. So I initialize all of them with 0. Now, prefix sum of I. For a particular prefix sum, what do I need? the previous prefix sum and the current value, right? I just add these two terms up. The previous prefix sum is basically I minus 1 and current number, since it's zero based indexing, you do A of I minus 1. That's it. And this is your prefix sum. Let's just print it for you to see. 4, 1, 2, 3, 4. See, like starting with 0. 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 9, 10. Okay. So this is like the building of prefix sum. Very standard, very simple code. And now let's come to the queries part. Let's say there are q queries and I want particular index, sum up to a particular index, right? See out prefix sum of index. That's it. So this index usually in a code chef, code for whatever environment you are, this is basically one-based indexing, more or less usually. So since it's one-based indexing and my prefix sum is one-based indexing, I don't really need to offset it by one. Basically, this is one-based indexing, right? First element ka sum is up to this one. Second element ka sum is here. Third element sum is here. So if my queries are one-based indexing, so I don't need to offset it. If they're zero-based indexing, I need to offset. So let's say I have 5 queries, 4 queries, and give me up to 4, up to 1, up to 2, up to 3. Up to 4, the entire sum is 10. Up to 1, the entire sum is 1. Up to 2, the entire sum is 3. Up to 3, the entire sum is 6. So this is a very standard part. Now, why are we doing this? Because what is the other case? Why, like, if we're not using prefix sum, how will we calculate this? Sum of a prefix. A brute force way is just directly iterate, na, for every single query. Correct. But now the worst case is what? Let's say for every query, for all q, I ask you, give me sum up till sum of n terms. Now, if I tell you sum of n terms for every single query and you iterate for every n, so what is happening? There are how many queries? 1e5. There are how many numbers? 1e5. So you'll be iterating 1e5 for 1e5 times. So this is basically multiplying. And this becomes 1e10. And as you know, this is TLE. And what is prefix sum helping me do? This entire step, how much time is it taking to build this sub prefix sum? So prefix sum build time is O of n and query time is O of 1 because at the end I just need this, na, the index ka prefix sum. This is just O of 1. I directly go to that index. Fair. So this is the power of prefix sum. Instead of O of n into q, I made it. So this is overall n plus q. because N for building, Q into 1 for queries. So I just converted this multiplication sign into plus sign. Okay. So that this is the very like first step of prefix sum, and hope you understood it properly. Yes, no, just write it in chat. Perfect. Now let's do something advanced, like something more good. Like this, so you might have an idea. Okay, I can take this prefix sum and you can get the idea. But now let's just make this query a bit more complex. No, wait. Yeah, same thing. Let's just copy this. I don't want sum. I want ZOR. How will this code change? I want someone to answer. Hello. My question is same. Instead of sum, I'm doing ZOR. How will I change this? How will I code it? Yes, we use XOR instead of plus. So here, since we're using plus here, we can use a XOR. That's it. And we can change its name to prefix XOR. Whatever you want. But yeah. So now a question might be arising to you all. I can take for sum. I can take for XOR. Can I take for any operation? The answer is no. Why is that? And why only for some operation? And which type of operations will I use prefix sum or prefix for? In maths, while you were learning like normal algebra, addition, subtraction, multiplication, division, there might be a property people might have told you, associative property. Associative? I don't know, wait, it was distributive. Might. Distributive property. What does it say? If you have an A plus B, oh no, it was associative only. No, no, no. Equal to A plus, first you take these two terms का sum. Right, this is basically same, right, for addition, and that is the associative property. Yes, and this associative property basically holds for XOR. I can do XOR here. I can do multiplication here. I can do subtraction here. I can't do. I can't do division. Can't do division. Or and also I can't do. I can do or also. Right. And I can do like have it. This I'll come to the topic a bit later. But I can do and I can do GCD. I can do GCD. I can do LCM. All this fun stuff has this associative property. So if I ask you, I want GCD up to this range. from 1 to 10, 1 to 15, 1 to 18. GCD में you just do this. That is it. Very simple code. Okay. And if you want to read about it more, process of a property. Just Google it. Lots of stuff.
Help Buck Buck find the upper.
There. So yeah, just associative property not applicable for division. Like that. And even subtraction to this numbers. And you can just Google it or whatever. And now let's come to the change in the topic. The change as in a bit at a more advanced query. Let's come to here. Instead of sum of prefix, I'll ask you sum of range. Okay. Question remains same. I want sum, but I want in a range L to R. Earlier we were doing 1 to R. Now this also can change. Okay. Question understood? At least. The L to R hai now instead of 1 to R. Every single time. Perfect. So now, how do we do this? Once again, brute force way. For every L to R, just iterate, but iteration has the same issue. I tell you sum of n terms and becomes n into q, which is too much. I want this to be there, n plus q. So how do I do this? N plus q, right? Let's make a prefix sum, okay? This one is it. I'll write this term down. Let's make a name. 1, 2, 3, minus 1, 2, okay? This is my original array. If I say कि I want sum from 2 to 4, it is this entire thing ka sum, which is what? 4. Okay. Now since the topic today is prefix sum, you might have a hint कि it is prefix sum. Yes, it is prefix sum. But how do we do? You do this, I will show you. Let's make a prefix sum, okay? This is a prefix sum. Where this is how you build a prefix sum, and you have learned this here itself. Okay. Now, what is the sum up till the entire fourth index? 5. And what do I need? 4. So do you see a 1 here? If we just subtract 5 minus 1, do we get 4? Yes, no? We get a 4. But now how do we know where to subtract from and how do I know what to do? Okay. So now firstly, if I tell you prefix till 5, till 4. I have some from 0. Let's say I have 0, 1, 2, 3, 4, 5, 6. Prefix sum just covers this entire range, right? It is a sum up till this entire point. Yes. And then I tell you, prefix 2. It is this entire sum. Yes, no. Now, what is my question asking? I want this sum, right? Let's make it better. ये पूरे का sum है. And this is entire thing. Now my range query 2 to 4 is what? This entire thing? Yes, no?
Yes.
Yeah. So now let's just overlap this. No, if I overlap this to here, what do I get? I want this shaded region basically, correct? So to get this shaded region, I need to remove this region from 4. Yes, no? For geometry, shapes, but yeah. So what is this entire shape? What is this entire shape? It is P of 1. Yes, no? This entire shape is this. I need to remove this from the entire prefix sum of 4. So visually also we can see uh, sum from L to R. Currently it is 2 to 4 is equal to prefix of 4 minus prefix of 1. Correct? We got this visually. And in terms of general terms, 4 is what? My R, and 1 is what? 2 minus 1. So that is basically L minus 1. And that is it. This is my equation. Correct? Yes, no? Does it make sense? Visually, did you see? Yes. L to R करे sum if I want to do. You do R minus 12. R minus L minus 1. How will I change this code? Can anyone tell me? I don't want to write this. Can anyone else just tell me how to I? What do I print here? Let's say I have an answer here. What will be my answer? Just tell me. I took LR as input. Prefix of R minus prefix of L minus 1. Exactly. L minus 1. So now if I tell you like the 4 queries, give me 1 to 3, 2 to 4, 1 to 4, and 2 to 2. Let's just verify. 1 to 3 is what? 1 plus 2 plus 3. Is it 6? Yes. 2 to 4 is what? 2 plus 3, 5, 5 plus 4, 9. It is 9. 1 to 4 is 1 plus 2, 3, 3 plus 6, 6, 6 plus 4, 10. And 2 to 2 is just 2 itself, so it's 2. Yes. So we verified it with code, visually, everything. So now this is done. So what did we do till now? We did prefix sum, prefix or, prefix. Technically, we did prefix GCD, prefix LCM, prefix multiplication. This doesn't work. Prefix and, prefix or, all of them work. Prefix or, prefix, whatever. All the associative things. Same things applies for here also. Okay. Here I can change anything, but wait. Now is a catch. Let's say I have prefix product. Okay. How will my formula change? Will it remain this? It won't. Yeah, we will divide here because that is the opposite of product. Opposite of addition was subtraction. Like we're removing instead of adding. Same for product. We divide instead of multiplying. Okay. And if it was for XOR, what will we do? If it was for XOR, what do you do? Nope. For XOR, we don't do OR. We do XOR. Exactly. Why is that? So now let's say I have 101, 110, and 100. These are my three numbers. Let's do a prefix OR. My prefix OR will be 101 here. When I'm XORing it, it will become 011. And I'm XORing it, it will become 1011. Yes, and this will be 0. This will be my prefix XOR. Now let's say I want to XOR these two numbers. If I have 1011 and if I OR it with this, what will be my result? If I do OR here, I'll get 1111. Is this 1111? This prefix, these two ka XOR? No, right? These two ka XOR is 0111. There is an extra one here if I XOR it. So that is wrong. If I XOR it, what do I get? Let's see. 1 gets cancelled out. 10 gets 1. 01 gets 1. And once again, 01 gets 1. Magic. If I just apply XOR here, it gets the correct answer. So why is this working? Does anyone have a guess or
More of same number is like gets cancelled.
exactly? So in, like, if I have 2 XOR 2, you get 0. XOR is adding also, destroying also at the same time. So XOR is a very special function. Uska inverse is itself only. For addition, let's just make this table. operation inverse. If I have a plus, its inverse is minus. If I have a multiplication, its inverse is divide. If I have a XOR, its inverse is XOR itself. Okay, good stuff. Now, can I do this same thing for AND or or GCD? Same technique. Yes, no. Can I or can I not? बोल दो भाई. Wrong answers are also good. You learn. Others also थोड़ा बोलो. Okay. So the answer is no. Why is it that? Okay. Basically, AND का AND's inverse. Wait, can I do this for AND? Is not AND, right? Like this is the inverse. Let's just try this. Same thing, 1 0 1 1 1 0 1 0 0 0. Let's have another one here. Make it one here. Okay. If I do prefix AND, what do I get? 0 here. Prefix AND, by the way, first number is all ones. Or else you'll get always 0 if you want to take prefix AND. But usually you don't need to do prefix AND level. And the second, even for GCD, it is 0. For this, it is you take 1 0 0 and you get 0 only, all zeros. Now let's say I want to take these two AND. Can I do anything with this? Yes, not AND actually works. Ah, fair. I think not XOR also might work. Let me give a terrible example. Ah, wait, yeah. Let this all be zeros. Okay. What is my AND gonna be? 0 here, 0 here, 0 here. Like throughout zeros. Now if I do not AND, I'll get this number. Is it correct? No. So that is why not and inverse technically. It is not distributed kind. So yeah, I don't recall the mathematical term for it, but you can't do for and, you can't do for or, you can't do for GCD, you can't do for LCM, whatever. To do these queries, technically you can, but for this you need more advanced data structure like segment tree, which currently you don't need to learn about. A lot of advanced stuff. No need to fret about it. You will almost never encounter this question in Div 2 ABC. So you're fine. Okay. Once you reach a level, then you can start. Okay. So yeah, we discussed about this thing, sum on a range. We discussed about prefix sum. let's do a different kind of question. Okay. Given n into n size grid, um, for q queries, find me sum of all elements in a rectangle given by x1, comma y1 and x2, comma y2. So more formally, let's just visualize this. Keep it and doesn't really matter. Yeah. So now if we have a x1, y1, x2, y2, this is part of this rectangle, right? So I want this entire six cells ka sum. How will I do this? Hint, prefix sums, but in 2D. How will I do this? Like any idea? What is superposition, Adit? If you can speak, just
हेलो हेलो
हाँ
तो आप एक्सकैलिडर दिखा सकते हो एक बार
हाँ
तो जैसे x1 y1 तक प्रीफिक्स हम निकालेंगे एंड x2 y2 तक निकालेंगे
ओके
देन दी अपर पार्ट को हम लोग माइनस कर देंगे मतलब
हाँ
जो
ओके ओके
x1 y1 वाला पार्ट है
हाँ हाँ ओके ओके यू आर करेक्ट बस ठीक so now Adit is correct but how do we visualize it and how do we do this? I'll tell you अच्छे से with equation also and stuff. So if I want to, I will forget about the rectangle, okay? Currently, if I want to do prefix sum in this 2D plane, what will I do? Let's say I have 1, 2, 3, 1, 2, 3, 1, 2, 1, 0, 1. And let's just have all ones here and all zeros. Okay. Now, prefix sum 1D में क्या था prefix sum? What was the prefix sum? 1, 2 are yes. So if I want to make a line into 2D, what do I get? Like if I extend this line the same dimension and I make it 2D, I get a square, right? Square or rectangle, whatever. I get a rectangle here if I just extend a line into 2D. And to make 2D to 3D, you make it a cuboid. Okay. So now since this is a line, this becomes a rectangle. Now prefix sum in a rectangle, how will I calculate? This and it should start from 1 because idhar bhi we are doing from 1, na? You start from 1 comma 1, okay? For this, uh, only for like okay, for this entire row, what will be my prefix sum be? What will my prefix sum be? It will be normal prefix sum, right? Will I do any changes over here? Yes, no. Because if I want to make a rectangle from 1 comma 1 comma 2, it will be this part only, which is just prefix sum, like the 1D thing we did, right? Yes, no. The answer is yes. So let's just do that. You get 3 here, you get 6 here, you get 7 here. Let's erase. You get 9 here, and you get 12 here. Okay, wait. It will be better if I make a new one. Okay. For this entire rectangle, it is 1. This is 3. This is 6. This is 7. This is 9. And this is 12. For this part, this column, is it once again just prefix sum? If this entire rectangle is a prefix sum, right? This entire rectangle is a prefix. I don't need to do some special things. I already know how to do this. Yes? Do you understand, like, first one, first column, कैसे build हुआ? How do I build that? Yes, no. Yeah. Now let's say I want this. I want this rectangle ka sum. Okay. In prefix sum, what we used to do? Right. In prefix sum, we did this, no? We go to the previous value and add the current value, correct? Now for this number, what can the previous values be? Can I just take only this? Yes, no. Only ऊपर वाले का sum? No, correct. Can I take only right का sum? Only left का sum, sorry. No. I need to take both left and right ka sum. Because this tells me it is this rectangle. This tells me it is this rectangle. Like more formally, let's say I have a, okay. The above cell tells me it is a sum of these two numbers, right? Let's color code. Professional. And this one tells me it is a sum of these two numbers. Okay. So for me to get this entire ka sum, I need this value. I need this entire value, and I need this value. Correct? Yes, no? Yes. But now there's a problem. Let's see the problem. Okay. Let me take the sum of this plus 2. What do I get? What is 2 plus 3 plus 2? 7. And let's calculate the sum manually. 2 plus 2, 4, 4 plus 1, 5, 5 plus 6, 5 plus 1, 6. Damn. 7 is not 6. How do I get 6 now? I have done some error. No? I have done some overcounting. So that is where the concept of inclusion exclusion comes from. You might have heard that in set theory, JEE में 11th का first chapter. But yeah, since this is the entire sum and this is the entire sum, how many times is this cell getting counted?
2 times.
Exactly, I need to
Twice.
subtract once, no? So now here I've changed the formula and I do -1 and I get a 6 here. Let's just erase this. Huh. I got a 6 here, which is correct. So now my formula becomes this plus this, either plus, either plus, and minus. Okay, and you have this cell kapura in as itself. So what does my sum become? 6 here. Let's just do this first same thing, no? 6 plus 6, 12. 12 plus 1, 13. 13 minus 3, 10. Is it 10? Let's just see. 1 plus 2, 3. 3 plus 3, 6. 6 plus 1, 7. 7 plus 2, 9. This is 10. Damn, this is working. 7 plus 10, 17. Minus 6, 11. 11 plus 0 is 11. And that's just it. You just calculate this forever. Now, this is an example where it was only one cell. But let's say I make a grid here. And I want to calculate this. It's a this index curve. So what does it above one signify? Above cell. It is this entire rectangle. The left hand side is this entire rectangle. And if I want to remove something, I want to remove this entire region. No? This entire thing is getting counted twice. So what is this entire region? It is just iska value, right? Because this signifies this entire range. Does it make sense? That's why I'm taking above ka sum, left ka sum, minus up left ka value. Does it make sense? Like
Yes.
visually, yes. So that is it. So what will be my formula? In prefix sum, we had a formula like this. What will be my formula for 2D prefix sum? So a particular prefix of I, j equals what?
A of ij plus
A of ij plus
j minus 1.
T of
I minus 1 J
I
and
minus 1.
J
I
I minus
minus 1 j
prefix of I and J minus 1
Yes.
and
And prefix of
minus
I
A of
minus 1 j minus prefix of I minus 1 j.
what? And minus?
Minus prefix of I minus 1 j minus 1.
Exact. So this is my formula. This you only said, no? From not knowing, you've now derived this formula. Good stuff. So now, since in prefix sum, a good thing we did was offset by 0, right? we are at this value, so that if I'm counting this off by like doesn't go to -1, correct? For prefix sum in 2D, what do we do? We make an entire row like this, an entire column. That is it. And this entire thing is covered with zeros. This is all zeros. So what this helps us in doing, why this helps us is, let's say I want to calculate for this, the first number itself. I get 0 plus 0 minus 0. So I don't need to modify my algorithm. मुझे इसके लिए अलग से calculate करने का अलग कोड नहीं लिखना पड़े. इसके लिए अलग कोड ना लिखना पड़े. I just have this in a for loop and it just works. Magic. Okay. So let's come to the code. Let's do this. Put this in lecture 3. Prefix sum 2. Here you have n comma m vector matrix. This is the input of the matrix. Now let's make the prefix of. You know why I'm doing this +1, right? Because I'm offset. I'm making it 1 based indexing. What was the formula? Can anyone just help me? बोल दो भाई formula. I want you to type instead of me. मुझे तो आता है.
F I J.
Is it ij or I minus 1 j minus 1? This is
I
1
I
base. This is
I minus one.
yeah. So instead of this, like instead of doing I minus 1, a better way is initialize the matrix only by this. And I take input from 1 to n. This just makes it easier. Okay. Does this make sense? I made this also 1 base indexing. So the prefix be
Yes.
1 base indexing है तो doesn't really matter. Then prefix sum, or it's not a, it's a matrix. Prefix sum of, बोलो बोलो,
I minus one J.
I minus 1 j,
I J minus one.
I j minus 1, plus or
Minus
minus, minus,
mine. I minus one J minus one. Prefix sum.
so that is it. Now let's print this value. Let's make a very basic matrix 2 comma 2, wait, 3 comma 3, 1 1 1, 2 2 2, 3 3 3. Hmm. what is this is this. Yes. So do you see this is the entire sum 1 plus 1 plus 2 plus 2 is 6. 3 plus 6 is 9. And this entire sum is 80. Makes sense? Yes, our code is physically working also. Perfect? Yes, no?
Yes.
Good. Now if I tell you, now for the queries, how will you do this? Now the question is same. I've built this entire prefix sum. Now I want this thing, rectangle का sum. Prefix का sum was तो just this number I comma j का. But now how will I do this for a rectangle?
Here n comma n would be, sorry, n minus 1 comma n minus 1 would be the sum of rectangle.
No, I am talking with. No. If this is the matrix, I want this entire part, not this entire. How will I get this rectangle? Use the same principle we used here, but this is a bit different. So this is, let's say, x2, y2, and this is x1, y1. Just let me know.
x2 y2 तक लेके बाकी का सब्ट्रैक्ट कर देंगे.
हाँ, x2, y2 लेके बाकी का सब ट्रैक कर देंगे. Yes. But how do I know बाकी का कैसा? For example, this is my x2, y2, this entire region. In normal prefix sum, what do we do? इसका -1. Yes. So we'll be doing, if we just follow the normal prefix, we'll subtract this and we'll subtract this, which is just completely wrong. I'm leaving out these numbers, right? How do I subtract बाकी का is my question.
Subtract till like first like x1 x1 y2 तक, like that.
हाँ, we instead of x1 y1 we do this. No, I want to remove this entire
Yes.
thingy. This is basically x1 minus 1 comma y2. Correct?
Yes.
Because I want this number. No, I don't want this number to be subtracted. Same goes for here. What is this? x2 comma y2 minus 1. Sorry. y1 minus 1. Yes, no.
Yes.
And now once again there is an overlap. So what do we do?
Add कर देंगे इसको.
Exactly. We add this, which is x1 minus 1, y1 minus 1. Correct? So my formula becomes sum of x1, y1, x2, y2 equals prefix of, बोलो बोलो, keep it interactive. What is the first thing?
x2
x2,
y2
then plus minus what?
minus
Minus prefix of
x1 y2
x1, y2,
x1 minus 1 y2
x1 minus 1, y2, then plus minus of
minus
minus prefix of
x2 minus 1 x2 y1 minus 1
then plus minus.
then plus the common region
What is the common region? ऊपर वाला. Yes. x1 minus 1 and y1. Okay, this is the formula. I know this is thoda complex, but yeah. Does it make sense?
Yes.
Yeah. Let's just do that. x1, y1, x2, y2. Prefix sum of x1, x2, y2 minus prefix sum. And we have answer. This is my formula. Let's just give you three queries. Let's say I want this to this. This is 2 comma 2. So 3 comma 3. Let's say I want 1 comma 1 to 2 comma 3. Let's say I want 1 comma 2 to 3 comma 2. Let's see the answers. Let's say 2 comma 2 to 2 comma 3. 2 plus 2, 4, 4 plus 3, 7, 7 plus 3, 10. Is it 10? Yes, it is 10. 1 comma 1 to 2 comma 3. 1 plus 1, 2, 2 plus 2, 3, 3 plus 2, 5, 5 plus 2, 6, 6 plus 2, 9. It is 9. And 1 comma 2 to 3 comma 2. 1 plus 2, 3, 3 plus 3, 6. It is 6. Damn! We solved this question. Crazy, right? Any doubts? Yes, no? Hello.
Yes.
Perfect. We last topic and then we'll end this. So yeah. By the way, this 2D prefix sum, just to let you know, it was. Wait, I'll end the stream and I'll let you know. Very cool thing about this thing. But yeah. Last topic. Wait, huh? And the same thing you can do with XOR, you can do with whatever. Okay, you can do it with XOR, you can do it product, whatever. Okay. Now coming to the last topic. Let's say given n size For Q queries, we want to add X to all numbers between L2. After all queries, print the array. And one. Does this question make sense? I am given queries. I want to add X to all the numbers in this range. So let's say I have an array like this. 1, 2, 3, 4, 5, 6. Okay. My first query tells me add do +2 to these three numbers. Second query tells me do +2 to these two numbers. Third query tells me do +5 to these four numbers. What is my answer? My answer will be 1, then 9, then 7, 12, then 30, then 6 plus 11, then 7, 12, then 11. This is my final answer. This is what I need to print. Does it make sense? Input will be 5, 6, 1, 2, 3, 4, 6, then 3. First query is 3 to 5, add 2. Second query is 2 to 3, add 2. And third query is 2 to 6, and this is input. Anything you might know, or how do you solve this? Huh? Just speak out. Raise hand
Like
question.
what would be my approach? कि जैसे कि पहला क्वेरी है 3 ऐड करना है 5 क्या ऐड करना है लाइक पहली क्वेरी
2
में क्या
add करना है to this range.
3 to 5 तो like at 3 position like I will first initialize an empty array of size n.
Okay.
Then at 3 I will put 2 and like at 5 I will put -2 और वैसे ही मतलब हर एक इंडेक्स पे जैसे कि 2 और 3 है उधर भी वैसा करूँगा 2 और 6 है वैसे ही करूँगा और फिर स्टार्टिंग से इटरेट करूँगा लाइक जो मेरे को
Okay.
नंबर दिख रहा
हाँ
है
हाँ हाँ ठीक है. Your approach kind of correct. एक जगह you missed up, but ठीक है. Works.
लाइक दैट ओनली
हाँ
कि स्टार्टिंग से इटरेट करूँगा अगर कोई नंबर मिला तो उसको ऐड करते जाऊँगा और लाइक एक जगह पे प्लस कर रहा हूँ तो माइनस भी हो रहा है लाइक
हाँ हाँ वही. I'll tell 1, 2, 3, 4, 5, 6. Okay. Since the topic is prefix sum, you might have a hint कि भाई prefix sum तो use करना ही है. But कैसे use? Let's say I have 1, 2, 3, 4. Firstly, original array. Does it really matter? मैं अगर queries को process करूं, बाद में मैं original array को add करूं, is it the same? So currently, do I really need the original array to process the queries? Yes, no.
वापस बोलना.
Now see, the queries happen regardless of original array का क्या value है ना.
Right.
So do I really need the values of original array currently while I'm processing these queries?
I mean,
No, yes,
uh,
exactly. And one more thing, can I iterate? Like, can I do it manually? Like, I manually assign +2 to 3, 4, 5. I manually assign
रियली
+2 to
अवॉइड
2, 3. Yes, no. No, right? Tail ही देगा. Same logic. N into K
टेन ही
वाला.
आएंगे हाँ
Exactly. इधर है. हाँ, this logic. N into K. So now, how do I do this? See, if I don't want to do it manually, what kind of hack can I do it? If I want to add 3 to 5, what does that mean technically in terms of adding? Let's say मुझे 0, 1, 2, 3, 5, 6.
मतलब
Huh. If I want to add, if I want to do +2 here, +2 here, +2 here.
पूरे का प्रीफिक्स हम 6 से बढ़ जाएगा मतलब
हाँ, पूरे का prefix हम 6 से बढ़ेगा ना, exactly. So now if I do +2 here, if I just do 2 here, okay, I want to end this prefix sum up to this point, correct?
राइट
तो अगर मैं इधर -2 ऐड करूं, तो will I end that prefix sum? Basically, if I'm doing +2 here, this entire range में +2 हो रहा है, end तक, correct?
हाँ
अगर मैं उसके बाद prefix sum ले रहा हूं, ठीक है? I'll take prefix sum later. So if I encounter 2, तो इधर भी 2 आएगा, इधर भी 2 आएगा, इधर भी 2 आएगा, इधर भी 2 आएगा, correct? Now if I do -2 here, what does that mean?
वापस से 5 पे चल जाएंगे
तो बेसिकली मैं ये वाला पार्ट सबट्रैक्ट कर रहा हूं फ्रॉम दिस एंटायर रेंज. दैट
यस
मीन्स मैंने ये रेंज पे ऐड कर लिया ना. बेसिकली 3 to 7 I am doing +2. Then I am removing, I am doing 6 to 7 -2. So what does that mean? 3 to 5 जो है, that will still have the +2 ना at the end of the day, correct? Yes, I just removed this entire thing. Hello. Yep. So yeah, that's what you do. Now, like more formally, if I'm given L, R, and X, I do A of L पे plus equals to X and A of R plus 1 पे minus equal to X. That's it. So let's just do this now. Let's just simulate. तो मैंने ये किया. Now 2, 3, 2. That means either +2, either -2. Correct? Then 2, 6, 5. Either this becomes 4 and either you do -4. Correct? Yes, no? Either it was 0, either it was 0. Now when I take a prefix sum, I get 4, 2, 0, 2. Oh, wait, sorry. 4, 6, 4. 4, 6, 4, 4, 2, 0. Does this make sense?
-2
Hmm? Either 0 0. अरे हाँ, वो -2 doesn't really matter at the end. Just like the last element, वो फर्क नहीं पड़ता because it is index out of. रुको wait. Technically, it should satisfy this. 6. Why is this not? Why is this not? अरे हाँ. Oh, this is 6. My bad. इसलिए wrong. Technically, it should balance it. Because if you see at 2, and if it's 5, make it 4. Make this 4. If you see at 2, concept 2 plus 4, 6, it is 6, yes. 3, it is 2 plus 2 plus 4, that's 8. For 4, it's only 2 plus 4, that's 6. 5, it is 2 plus 4, that is 6. 6 के लिए only 4, तो 4. So does this make sense? We have made this array, no? Yes, no? Huh. So bus, I just take this, I do prefix sum, and then I just add it to the original array. Original array पे add करते जाओ. So you do plus 1, 0, plus 1 is 7, plus 2 is 10, plus 3 is 9, and so on. Okay. So bus, why here? You just have to do this. Let's come to the code. Let's put it on lecture 3. And this topic is called difference array or partial sums. You can search it up online to have more idea, but yeah, let's just take this input. LLN. Now I make a difference array of size n plus 2. Why am I making it n plus 2? Because I need padding here and here. Because I just need one padding ahead, but ठीक है. नहीं, I need padding one ahead. Because for prefix sum जो end में करना है, I need this value, right? 0th value. And for r plus 1, if I query 6 पे, so r plus 1 shouldn't go out of bounds. That's why I do padding here as well. So that's why n plus 2. Now, while q minus minus, what do we do? Difference of n x also. And difference of r plus 1 and now wait a second. What is wrong? Ah, this is it. Oh, yes. Yes. So that is it. This is your prefix sum. This is your array. Now I'll explain the code line by line. This is what we did here. Then prefix sum, if I want to do it on the array itself, so I already have difference of I, na? Instead of doing difference of I equal difference of I minus 1 plus difference of I, we just add the previous term. Okay. Much more elegant, much more simpler. And at the end, I'm doing I plus 1 because this is 1 based and this is 0 based indexing. Same thing, you can do this also, but not really. Makes sense? Code समझा लोगों को? Yes, no? Cool. With that, I'll end the stream. Bye bye. Like, share, subscribe. Meet you tomorrow because Dhyanesh is taking lecture.